are mostly going to be on hard substrates, so if you're looking at things that are actually on the nodules, these might be potential things that you'll find. And this, a lot of chitons have been monographed for many decades. I believe it started in the 1980s. And even though both the original authors died, there was a final volume published in 2006 that included one of the last superfamilies. So a very useful volume. Also some more modern things, and again, this is out of the French tropical benthic studies down in the South Pacific, done by Boris Sarenko, who's probably one of the top polycopheran people today. Another series I want to point out to you that might have some application. Out of our museum, we put together a series of benthic identification guides. We did 14 volumes called the Taxonomic Atlas series. While this did not get down into this, it certainly got into the deep, and we got into about 1,000 meters. And in some cases, these are the only references available that are anywhere close to our study zone. So for the aplecopherans, the non-mollusk looking mollusks, the worm-like looking mollusks, there's a nice series here done by Amal Sheltema. That was done in 1998. And then recently, another local group in Southern California called SCAMET, which stands for the Southern California Association of Marine Invertebrate Taxonomists, put together a really nice guide. And they got down, well, we can't really see the numbers, but they got down to about 1,000 meters, again off Southern California, and looked at the aplecopheran species there and gave all the characters and put together keys. So useful information, at least to get started, maybe to family level. This association, I might say, this SCAMET group is very similar to what we have in this room. So it's a group of professional taxonomists, it's a group of contractors, it's a group of academics that all have gotten together and have normalized their data set. This is what they do. They get together once a month and say, okay, we're going to talk about this family of isopods, and they all talk about what they have and put it together, and number one, they document it. Every month they document what they found, and you use that going forward. They put it together in a tool on the web, and it's quite nice. Very nice model to use, potentially for this group. Scaphalopods, again, we're going back to some of the French expeditions. Very nicely done. These aren't necessarily down to the abyss, but certainly deep. You know, they're past the shelf break and going down, maybe down to 1,000 meters or so. Gastropods, sadly, so the most diverse group of mollusks, the gastropods, sadly are pretty darn poorly documented in the Pacific at this point. And that's really frustrating to so many people. So where we start is the Challenger expedition way back when, and I believe this was done in the 1880s when Watson did this particular one, is really the big monograph that includes most of the Pacific deep sea mollusks, and then modernized somewhat by Okatani and Keene. So these are still your two best places to go. And none of them are going to be perfect by a long shot. This Taxonomic Atlas series, we did include gastropods there. This was done by Jim McLean at the Los Angeles County Museum. It does get down to about 1,000 meters, so at least you get some moderately deep Pacific things. He also included keys. It's very well illustrated, so it could be helpful. I brought a copy of that as well. And one other group, so usually we're looking at more localized group, and one of the things that we've been doing out of the Santa Barbara Museum is to try to publish these large monographic works because, well, we can. We don't have a publish or perish kind of thing. We can spend 10 years on a book and get it done. So Daniel Geiger monographed all of these microgastropods. These are usually about 1 millimeter in diameter. You're going to find some. You're going to think they're juveniles. But he monographed them worldwide. In the front, so I can't remember, I think there's about 350 species in this one sort of super family group. They're all very well documented in terms of things that you and I can kind of understand, which is the shells. But he also did microanatomy and looked at gradula and things like that if you really want to get into it. Daniel also works in my lab and is probably going to help on these things as well. So, how do we, when it gets down to nuts and bolts, how do we identify all these things? Unlike what I've heard from some of my colleagues, we have put together keys. Or I have put together keys for bivalves, let's put it that way. Whether this will work precisely for your study region, I'm not sure yet. We'll find out. I'll see when we're working with the specimens. But my goal, actually I should tell you a little bit about my background. I'm an ecologist and started my career as an environmental monitorer. And the reason I turned into a taxonomist is because I couldn't identify anything because there's no literature, right? So I decided to write it. I mean, that's my career path. So when I put something together, I'm thinking of you, just so we can get the job done. And so I really work hard to get tools together that are understandable. And along with keys, I put together tables. So I'm not satisfied with family level identifications. I'm not satisfied with generic identifications. I want it done to species if we can do it. I mean, sometimes they're too small, or sometimes they're damaged and you can't do it, but I want to see you do it if you can. And so I put together tools to do that. Whoops. Sorry, let me go back here. I put together tools to do that, which give kind of thumbnail sketches, a few quick characters, and really a description of what those characters are about. So when I'm talking about, and some of this is just a language thing, so being an American, I think horseshoe-shaped imbricate spines. Well, maybe nobody else would have any idea what that means. So we try to talk to you about what that's about, and training is part of the business, as far as I'm concerned. But then we go into great detail and long descriptions and distributions and a key to the literature for each species and good illustrations. Frequently we try to illustrate the types when they're really small, which I'm sure you're looking at a lot of small bivalves. We do SEMs. So a few quick things on collecting, and it's less collecting and more processing. So when you get these big box scores up on deck and you don't want to take home a huge blob of mud, I'm assuming that most of you are doing some onboard sieving. I certainly did when I was collecting. And the bottom thing is don't get the fire hose and put it on a sieve, because you're gonna smash everything. You're gonna do that to your polychaetes and your amphipods, and certainly the mollusks will just turn to mush. So when I was working at Oregon State University, we developed a sieving system. The sample goes in the top. We slowly percolate it down through a series of sieves to just get out most of the mud where you can. And it takes a little bit of time, but it makes the sample size easier, makes preservation better. Some of my colleagues down in Southern California use a similar type of system where a big sample goes in here, it's kind of gently washed through a series of sieves. The whole word is gentle all the way down, so these things don't get smashed, fragmented, all of our diagnostic characters disappearing. So you're spending, and in fact Renee said it, we spend so much time getting a single sample, spend that extra few minutes on deck to make sure it comes home safely. So this is probably not an issue for many groups, maybe except the ostracods. So formalin is not my friend. I don't mind. I'm not a molecular biologist, so it doesn't bother me that things go in formalin. I mean, my preference would probably be alcohol. But formalin will strongly react. It's very acidic. It's going to strongly react with the calcium in the shell. A lot send something like this to Daniel Geiger, you know, you've got these little schizurellas, he's just, yeah, it's useless. It's no use. So as soon as practically possible, as long as the sample is preserved well enough to your satisfaction, which might be a day or two, that I like to get it out of formalin and into alcohol. So that's just something I recommend if you want to have useful specimens in the world of mollusks. Sample sorting, so shells are important. I use soft forceps. I don't know if any of you use these things, but they're made of like spring steel. They're also called live insect sorting forceps. And I just love these things to death. We get them from a place called Fine Scientific Tools. They're about $30 US a pair. One pair can last you many decades. Well, actually, I should say that, because whenever someone visits your lab, those pairs always walk off somehow. So, well, a pair lasts forever. You just have to keep, I say, I will give this to you for the next hour, but I need it back. Honestly. Yeah. So we have to have a special cache, because we just know there's going to be, they'll disappear. They're very, very useful. They won't smash my shells. They won't smash the polychaetes. You know, they're really, really nice to use. So I highly recommend it. So, bottom line, in our region, bivalves, from what I found, I haven't seen any. I'll be seeing samples in the next couple days. I look forward to seeing them virtually undocumented. No surprise, potentially many new species. I look forward to seeing those. And just real quickly, some of the things that you probably have seen or might see. So a group of taxons, that's things with these big sharp teeth kind of all in a row, are going to be very, very common in the deep sea, and I'm guessing in your studied region. A similar one, so this is also a taxon. You can see this nice little comb of teeth. These are fairly thick shelled. They can stand up to your hard forceps. These guys, if you use hard forceps, they get crushed. I can't do anything with them. Or you can't do anything with them, more importantly. So the Oldias, heftier ones that we really like. So these are both pretty small. These are in the 3 to 5 millimeter size. These guys can get to a couple of centimeters, Lemopsis. They're really hairy, kind of fun, furry little clams. And a similar one, and these might attach to the harder substrate, so could potentially actually be beyond the nodules, are some of the arc shells. So this is a good synopsis of these taxodont types, all that have a whole series of teeth. Many different types of deep sea mussels. The ones that live in soft sediments are these dicreuids, also very thin-shelled, easy to break. So on a sieve or with forceps. Some of the ones that tend to be a little more associated with vents or cold seeps, but we're going to see from your samples some of the benthomodiolids and bathymodiolids, many of which are new. New ones are being described almost every week, it seems like. New ones are coming out. Glass scallops, I'm sure you'll find those, especially in your sledges. You know, they'll be picking up those by the bucket load, I would think. Quite a diverse group. When I first started doing these big monographs, I looked at these and went, oh, these are way overnamed. They're much simpler. And then in the end, it was just the opposite. There were many new things that we hadn't seen before, and they're much more diverse than we would have thought. Vesicomyids, again, normally thought of as a vent-type animal, but there's also vesicomyids that are definitely living in the sediments, that are smaller. They don't even look similar, but we have done the molecular work on these, and they are monophyletic. So you might see some of those. They look like small little globes when you find them in the sample, quite iridescent. And maybe even most common are all the anomalidesmatids. All of these are quite thin-shelled for the most part. They can be iridescent, they can be translucent. Most of them, interestingly enough, are carnivores. So they're eating those little ostracods, and they're eating the Taneids, and they're eating some small polychaetes. So we don't think of killer clams, but they are out there. And actually, I want to back up real quick here to talk about one thing. And that is, if you ever send samples or photos of samples to any taxonomist that does bivalves, we need to see the inside. Okay? Outside photos, not helpful at all. So that might get us to a family, but not much beyond that. So a quick summary. Surprisingly, this literature, this 19th century literature or mid-20th century literature is still very important in mollusks. And all that I can download, I have downloaded and put it on the ISA server, so hopefully that'll be accessible. Bivalves potentially are moderately well documented, but certainly many new ones. All the other molluscan groups. I haven't included cephalopods, by the way, because I'm kind of thinking they're going to get on it. Please don't crush my shells. Don't dissolve them. Can't do much with them. You're like every other taxonomist you talk to, we're going to have many new species. Document them, photograph them like crazy, because we can help from that. And most importantly of all, we kind of danced around this, but the samples you're collecting, the things that you're sorting out are so important to the future of understanding the deep sea. So please cherish these things. If you're going to pitch them out, you need to use the glassware again or something, send them to us because we'll take care of them. Or find an institution in your own country. It's really, really important material. So I can't emphasize that. I'm a museum guy, and I've seen it happen. I've seen stuff pitched up. I heard a story at lunch. It's like, no, don't tell me this. So we're happy to do it. It's an area that we're really interested in. The Pacific, especially the central Eastern Pacific, is right in our wheelhouse. So we want to deal with that. So with that, I think we're thank the ISA and our host institution for inviting us.
Thank you very much, Paul. Any question? Yes.
I just wanted to comment on the usage of formalin, because what we do is we actually buffer our formalin, so maybe then you don't have that problem.
Buffer, it can work for a certain length of time. So I would say buffer, it depends on how long your cruise is, but it could get it back to the lab. But unless you're stirring them all the time, what I found is that the buffering tends to stratify out, and you're still going to have an acidic part of your sample. So, I don't know. I've seen other people shaking heads and things. It's best to get it out as quickly as you can.
Okay.
So, buffering helps, though. So thank you for that. So that definitely reduces the acidity for some length of time. Long term, no way. I've seen that. I've seen long-term things stored in formalin that were buffered and they're just gone. So I would get a bunch of clam bodies and I can't do anything. I could give you family, maybe. Probably not even that.
Okay, we'll keep that in mind.
Yeah, thanks.
Any other questions? Thank you very much, Paul. And we pass to the last presentation of today. I remind you that at 6:30 the bus will be waiting for us outside to go to the kiosk. not to put pressure in Elena. And the next presentation is by Elena Wiklund, and the title is the Taxonomy and Biogeography of Macrofaunal Annelids, with the focus on the abyssal benthic Pacific fauna relevant to the current Gibraltar fracture zone.
documented worms. There are somewhere between 12 and 17,000 described species, depending on who you ask. I think on the World Polychaete database, there are around 13,800 exception names. So it's a fairly big group. And the molecular phylogenies, they also include oligochaetes, like the earthworms, and Sipuncula and Ecura as well. We still write Sipuncula and not Polychaeta for our books when we find them, but soon enough I suppose we have to go in there and decide. For the biogeography of this talk, we've already heard from Gordon that there's not that many described polychaete species from the CCZ. And that is despite this group being very common in all marine habitats. It's usually one of the most common groups that you get out in examples. With the early explorations, we heard about those as well from other speakers. For example, Challenger, they used mainly trawls. So they got big, epidemic, more or less, specimens that retained in the trawl all the way up to the water column. Their dominant polychaete family that they recorded from the deep sea, from the Pacific, they're the big ones, or living in big tubes like terebellids, lampreytids, and the scale worms, polynoids, and aphroditids. And here you can see some pictures from the expedition from Macintosh. So to the left there are the scale worms, the polynoids, and to the right you have at least one terebellid and the others are sabellids that also live in big tubes. But then later explorations, people started to use other gears, like box cores, megacores, and epidemic sleds. And they get some smaller informal specimens instead. And especially if you see one at 250 or 300 microns. And that shows a totally different pattern in the dominant polychaete families from these areas. So now it's not at all the